I'll show a useful feature of some of the more modern shortwave radios. This is the little Sony ICF 7600 communications radio that they've had around for quite a few number of years now. This is my old trusty Sony ICF 2010 that's coming on 25 years old. Had a lot of use, had a lot of modifications. It gets used every day to wake me up. Demonstrate the couple of the features that these radios have that not a lot of radios do. And the one I want to really point out is the Synchronous Detector. In a normal AM radio signal, you have your center frequency, which is, let's say we're working on radio 4, so we'll work on 198 kilohertz center frequency. So 198 kilohertz is the center frequency, and either side of that is the carrier. 9 kilohertz either side. Now the idea of the synchronous detector is twofold. If the signal's carrier fades in and out due to atmospheric conditions, you'll get a very distorted signal. The radio needs a carrier signal to be able to demodulate the audio correctly. And if that fades, the audio becomes very distorted. So I'm not sure if it was the Sony's invention, but Sony have actually mastered it with the original ICF 2010 with the synchronous detector. And what that basically does is it removes the incoming carrier frequency from the radio, and the set generates its own frequency, a fixed carrier frequency which is stable internally in the set. So basically the incoming signal is lost, and all that comes through is the modulated RF signal. This is great because, for example, here, and this is quite a good demonstration because my computer's on behind me, I've got a lot of noise on the radio. Now I've moved away from the radio so you can actually hear the difference, but the plan is to demonstrate the difference. What I'm going to do is, when I turn it to synchronous detection, the radio will generate its own internal frequency, but that's not the problem. The problem isn't with the carrier fading away. The problem is there's adjacent noise on one of the sidebands, either the upper or the lower. And the advantage with this synchronous detector as well is it will actually select which sideband you want to hear to. You'll get a reduction in quality because you'll get the reduced bandwidth of the AM signal, but that doesn't matter for medium wave, and it's barely noticeable anyway. So what I'm going to do is I'm going to show you the difference. I'm going to this is the radio on now. I'm going to move it towards the computer, and you can hear the noise from the computer interfering with the radio signal. You can still hear it, but it's still pretty annoying background noise. Now, what I'm going to do now is I'm going to turn on the synchronous detector, and you'll see the synchronous lock. You can see the synchronous lock come up. Now, it's got a synchronous lock, but it's actually locked onto the upper sideband. So it's all the audio information is coming from the upper sideband, but you can still hear the RF interference is still there. If I select the lower sideband, there you go. So all the interference is on the upper sideband, the lower sideband's clean, and you can hear the audio perfectly well now. So that's basically a really good addition to a shortwave radio, a synchronous detector. There is another way you can do it. It's not as effective, and the sound quality is never as good, but you actually incorporate the set's BFO. If you've got a built-in beat frequency oscillator and just adjust it to the right point, you won't necessarily get rid of all the audio, but you will be able to generate a stable carrier wave. And what I'll do is I'll demonstrate that by turning the set to its single sideband mode. Okay, and then I'm adjusting the BFO to 0 beat. There you go. You can actually, that's synchronous that's not synchronous detection, that's upper sideband mode, so the BFO is actually running at the exact right frequency for 0 beat. It's very, very touchy, this control, and any drift in the set will start to generate a background whistle. But you can hear by adjusting the synchronous detector, the beat frequency oscillator.
the professions or financial services industry, manufacturing industry.
Okay, it's not perfect sound quality, but you can actually resolve the signal quite well. So that's normal. That's normal AM reception with the wide bandwidth. That's synchronous detection on the locked onto the lower sideband, and beat frequency oscillator on. Here, reduction in sound quality, but reduction in interference as well. So yeah, I just thought you'd be interesting to see this video. Quite a useful feature of the Sony radios. I think a lot of the modern Japanese portable radios have it now, but I know a lot of my other sets, like the Yaesu FIG100, hasn't got that sort of feature. It does have obviously the single sideband reception. It doesn't have synchronous detection. The low HF225 has synchronous detector, but you can't actually select the sidebands you want, so it's nowhere near as good as the Sony set. But yeah, thanks for watching.